Okay, so for the remaining 2 weeks, we're going to be talking about graphing trig functions and inverse trig. And so that needs to start with making sure you recall and understand the unit circle. So we're just going to kind of recreate it and go over some basics. If you need another blank copy of the unit circle or you need a filled in copy, you can just do Google Images and do blank unit circle or filled in unit circle. To remind yourself, but you need to know this unit circle and you will need to know it very well for pre-calculus as well. Okay, so we start with the degrees because we all know that there's 360 degrees in a complete circle. We always start our angles on the positive x-axis. So that's why it starts at 0 degrees here, but then if we make a complete circle, 0 degrees is the same as 360 degrees. Every quadrant is 90 degrees, so we can kind of count around 0 to 90 to 180 to 270 to 360. And everything for special angles in the unit circle is related to the two special right triangles, which are 30, 60, 90 and 45, 45, 90. And so that's why we also want to chunk up our unit circle using the degrees 30, 60, and 45 from the two special right triangles. The 45, 45, 90, 45 degrees is going to be exactly halfway into each 90-degree quadrant. And then 30 degrees would be a third of the way into the 90-degree quadrant, and 60 degrees is 2/3 of the way into the 90-degree quadrant. So you can see this one's color-coded, that everything that relates back to the 45, 45, 90 special right triangle is marked in red. Everything that's related to specifically the 30-degree angle being near the origin for 30, 60, 90 is marked in blue. And it's still the same 30, 60, 90 triangle, but if the 60-degree angle is closer to the origin, then we mark that in green. Okay, so you can go around the circle and just mark it according to the degrees. Well, then what about the radians? So the formula for the circumference of any circle is 2 pi times the radius. Well, it's called the unit circle because the radius is 1. So that would be 2 pi times 1. So the circumference of the unit circle is just 2 pi. So again, if you start on the positive x-axis, 0 degrees is the same as 0 radians, but a full circle would be their circumference 2 pi. So 360 degrees is the same as 2 pi. So half of the circle would be half of 2 pi, which is pi. And half of pi, which is half of 180, is pi over 2. So those axes points that we got, 0, 90, 180, 270, 360, we can do the same thing with the radians, pi over 2, pi, 3 pi over 2, 2 pi. And then to get the radian measures, 45 degrees goes into 180 degrees 4 times. So 45 is a fourth of 180. So it is a fourth of pi, and that's why it's pi over 4. Anything that was related to the 45, 45, 90 triangle in the unit circle will have a denominator of 4. So you can see all the red angles are marked with a denominator of 4. Okay, 30 goes into 186 times. So 30 is 1/6 of 180, so it's a sixth of pi. So 30 degrees is the same as pi over 6. And anything that relates back to 30 degrees of the special right triangle has a denominator of 6. Those are all the ones marked in blue. 60 goes into 183 times, so it's also a third of pi. So anything that's related to 60 degrees from special right triangles has a denominator of 3 for radians, and those are all the angles that are marked in green. So some easy ways to remember what the related angle is as you move to a different quadrant. You want to have all the axes, angles memorized, and the first quadrant. You want to know those really, really well. Okay. Then as you move into different quadrants, notice that all of our reference angles in the second quadrant, the numerator is exactly 1 less than the denominator. So when you see that, you can easily place the angle in the second quadrant. As we move to the third quadrant, the numerator is now 1 more than the denominator. That's a quick way to place it in the third quadrant. In the fourth quadrant, a little more complicated, you need to double the denominator and subtract 1. So 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. 2 times 6 is 12, minus 1 is 11. Okay, those again are just easy ways to put your radian in the correct quadrant. And we need to know that because we're going to need to know these ordered pairs as well. So again, it's called the unit circle because the radius is 1. So to label the axes points, we always plot from the center to the edge of the circle. So if the radius was 1, then we go right 1, 1 comma 0, or up 1, 0 comma 1, or left 1, negative 1 comma 0, or down 1, 0 comma negative 1. So those are 4 of the 7 ordered pairs you need to have memorized. Then we have the ones from the first quadrant that are related to the special right triangles. So as you move out from the origin to the edge of the circle, that would be the radius of a circle. That's the definition of radius. We create special right triangles by dropping perpendicular lines to the closest x-axis. That would also be the hypotenuse of those right circles, triangles. So the hypotenuse is also the radius, which we've defined as 1. Meaning for our special right triangles, we always know the hypotenuse is 1, and then we can use our relationships of special right triangles to figure out what the opposite side and the adjacent side are. And that's how we're getting these ordered pairs. So for anything that is related to a 45, 45, 90 degree triangle, the two sides, the two legs of the 45, 45, 90 triangle, when the hypotenuse is 1, it's 1 over square root of 2, 1 over square root of 2. Okay, and you can see that that is the same ordered pair no matter which quadrant. If it's related to 30, 60, 90, and 30 is the angle closest to the origin when we have our triangle, then we get square root of 3 over 2 comma 1/2. Again, that is a 30, 60, 90 when the hypotenuse is 1 based off the 30 degrees being right here. And then it's the same triangle when we move to 60 degrees, but now the 60 degrees is what's closer to the origin. So the two values in the ordered pair have just swapped out. So it's the same ordered pair, but in a different order. And it's important that you remember that correctly. Okay, so we have the 4 axes ordered pairs to remember, and then the 3 in the first quadrant. Anything with a denominator of 6 should be square root of 3 over 2 comma 1/2. Anything with a denominator of 4 should be 1 over square root of 2, 1 over square root of 2. And anything with a denominator of 3 should be 1/2 square root of 3 over 2. The last piece of the puzzle is how we change those ordered pairs when they're in a different quadrant. So the one acronym you can use is all students take calculus. Okay, starting from the first quadrant and moving around, which just means all the trig functions are positive in the first quadrant, sine is positive in the second quadrant, tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. I don't really use that so much. Just think about, well, we're in the second quadrant. The only way we can be there is to go left and up, which means negative, comma, positive. So the same ordered pairs that we had in the first quadrant, but the x-coordinates are now negative because we had to go left and up to get there. In the third quadrant, you do the left and down. That's 2 negative directions. So same ordered pairs, but both the x and y coordinates are negative. And in the fourth quadrant, you go right and down, which means positive x, negative y. So again, same ordered pairs, except now we made the y coordinates negative. And then what are we going to do with these ordered pairs? If you know the right ordered pair, you can determine all 6 trig functions based off that ordered pair. So remember that every ordered pair with a special angle of the unit circle represents cosine, comma, sine. And then tangent is sine divided by cosine, or y divided by x. So if we can look at an ordered pair and determine sine, cosine, and tangent, then the sine goes with the cosecant, the cosine goes with the secant, and the tangent goes with the cotangent. So if we can determine sine, cosine, and tangent, we just have to take the reciprocals of those things to get the cosecant, secant, and cotangent. So one quick example before we're going to end this recall video. Let's say that I know that the angle is 5 pi over 6. Okay, well, I know that I've memorized that anything with a denominator of 6 is square root of 3 over 2 comma 1/2. 5 pi over 6 is in the second quadrant because the numerator is 1 less than the denominator. And if I'm in the second quadrant, I have to go left and up. So I'm going to take that ordered pair for pi over 6 and just make the x-coordinate negative to show that I went left and up. So once I've determined my ordered pair, the cosine is the x-coordinate. So the cosine of 5 pi over 6 is negative square root of 3 over 2. Sine is the y-coordinate. So the sine of 5 pi over 6 is 1/2. Tangent is sine divided by cosine. So the tangent of 5 pi over 6 would be 1/2 divided by negative square root of 3 over 2. The 2's would reduce out, so it would just be 1 over negative square root of 3. And again, cosecant, secant, and cotangent, you just have to find the sine, cosine, and tangent and take the reciprocals. Okay, that's it for your review. And the second video will be how do we graph.